So our topic is about sampling distributions. So after this discussion, you would, of course, try to understand the inferential relationship between a sampling distribution and a population parameter. Graph a frequency distribution of sample means using a data set. Understand the relationship between the sample size and the distribution of sample means. And the last one is understanding sample means. Sampling distributions. Okay, so I have prepared here, make sure, okay, another PowerPoint. So this PowerPoint here is about our topic, sampling and sampling distribution, but it merely just considers some of the salient points that you should understand regarding sampling and sampling distribution. So first is, what is a sampling distribution? Okay. So a single sample selected from a population will give an estimate of the population parameters by way of what we call the probability theory. Okay, so first is, let's try to distinguish first what is the population, what is sample. Of course, the population is the bigger group. The sample is the smaller group. Okay, so you take a sample from the population. When you say the population, it refers to the totality of objects, or we're referring to individuals that uh, under investigation or under study. Whereas if you consider what we call the sample is um, a smaller group which you obtain or you get from the population. Okay, so of course this one is a representative group of the population, wherein you can make estimates of population parameters. Okay, what is the purpose of sampling? Why do we need to get samples? Okay, so when we say sampling, since already knew about population and sample, sampling is the process by which you get samples. Okay, so actually I have not um, identified here because that would be for another set or another um, topic. Okay, so the purpose of sampling is to select a set of units or elements from the population, that is obtaining samples, that can be used to estimate the parameters of the population. Okay, so if you get samples from the population, instead of considering all the individuals or all the population itself, you will just need to study a smaller group, and that smaller group that you have studied can be used as an estimate for the parameters of the population. Actually, there are generally two types of sampling. One is considered the probability, and the other one is the non-probability. Okay, so it's not, I have not, as I said, it will be on a separate note, a separate discussion. But just to review what you mean by probability sampling, it means that every element or every member of the population is given an equal chance of being included in the sample. When you take the samples from the population, that means it's not biased. So you'll have to consider all of these elements, okay, for the probability sampling. So probably you can use several means of determining that. The other one, which is non-probability, it's some sort of a bias, no? A bias type of sampling, non-random, because all you need to do there is to select. okay, usually by convenience. Okay, random sampling. As I said earlier, random sampling is a special type of probability sampling that erases the danger of a researcher consciously or unconsciously introducing bias when selecting a sample. So as I said earlier, um, under probability sampling, there is no bias. No? So it erases the danger of a researcher consciously or unconsciously introducing bias when selecting a sample. Because when you are to apply random sampling, which is a special type of probability sampling, you will not be able to select by convenience. Okay, so all or everybody would be given a chance, as I said, to be a part of the samples. Okay, okay. So we're talking here as a parameter now. So when you talk of parameter, it is a summary description of a given variable in a population. Okay, so one good example is a population. So what is this parameter? Now, so these are the values or descriptions we should get from the population. Okay, so you call it as parameters. So usually the notations that are used for this are in Greek letters. Okay, so for the mean, I think we use the mu. Okay, whereas for the samples, um, the summary description of a given variable in a sample would be referred to as a statistic. Okay, first, the very essence of what statistics is all about. No? So all about research. So instead of considering the whole population, which is a very tedious job and time consuming, and of course if you do researches, it would also consider a big amount of money if you will have to consider all your population instead of just getting samples. Okay, so I think that would be the enough for these um, different terms. So first we have considered sampling distribution. What is the purpose of sampling? No random sampling parameters. So of course to understand more about what we'll be talking about here in our discussion. Okay, so let me uh, consider again our, okay, so this is our module now. So the one that you are reading in the LMS. Okay, sampling distributions. Some of this I have already mentioned in the um, PowerPoint presentation. Okay, so in addition, okay, random sampling allows us to use tools from the probability theory that provide the basis for estimating the characteristics of the population, as well as for estimating the accuracy of the samples. Okay, so probability theory. So I've also mentioned this a while ago. So first, random sampling is a special type of probability. So to make use here of the probability theory. Okay, what is the probability theory? It is a branch of mathematics that provides the tools researchers need to make statistical conclusions about sets of data based on the samples which obtained from the population. So as previously stated, it also helps statisticians estimate the parameters of the population. As I said, instead of considering the whole population itself, you just need to get samples to be able able to estimate the parameters of the population. When researchers generalize from a sample, they're using sample observations to estimate population parameters. So probability theory enables them to both make these estimates and to judge how likely it is. Estimates accurately represent the actual parameters of the population. So this theory enables researchers to both make estimates and then afterwards judge how likely it is that the estimates accurately represent the actual parameters of the population. So if you will have to consider good estimates, then you will be able to represent, no, the actual parameters of the population. Okay, so as mentioned earlier, also we have the sampling distributions as what I have already defined. So a single sample selected from the population will give an estimate of the population parameters. Other samples would give the same or slightly different estimates, but the probability theory understands how to make estimates of the actual population. Okay, so here is a scenario, no, that was presented in the introduction to this chapter. Okay, so the assumption was made that in the case of the population of size 10, okay, so there are 10 people or there are 10 persons being considered here. Okay, so one person had no money, another had $1, another had $2, another had $3, and so forth and so on until we reach the person who had $9. So there are 10 of them. Okay, from no money to $1 increasing each time until um, the 10th person would have $9. So the purpose of the task is to determine the average amount of money per person in this population. Okay, so if you're going to get the total from no money to $9, so okay, so adding them from 0, 1 up to $9. Okay, so adding them will give you an amount total or a total of $45. Okay, that's yielding a mean of $4.50. However, suppose you couldn't count the money of all 10 people at once. So let's say that you don't know, actually count all of them. So in this case, to complete the task determining the mean number of dollars per person of this population is to select random samples from the population and to use the means of these samples to estimate the mean of the whole population. Okay, so you take random samples from the population and then these um, random samples, you take the mean to estimate the mean of the whole population. Estimating population parameters from a small sample. Suppose you were to select, so this is how to estimate population parameters. So if you just have a small sample, it's like the previously given example. So suppose you were to randomly select a sample of only one person from the 10, how close will this sample be to the population mean? So the 10 possible samples are represented in a diagram in the introduction which shows the dollar bills possessed by each sample. Okay, so since samples of one are being taken, they also represent the means you would get as an estimate of the population. So for 0, you have 0. For 1, you have 1. For 2, you have 1. 3, you have 1. 4, you have 1. But the true mean is $4.50. So add the sum is 45 divided by 10. We will get $4.50. So they all have a number equal to 1 as the mean. So mean estimate. Each one is a mean estimate because you just get uh, an estimate from each one of them. The distribution of the dots on the graph is an example of sampling distributions. Can be seen, selecting a sample of 1 is not very good since the group's mean can be estimated to anywhere from 0 to 9. And the true mean of $4.5 or $4.50 could be missed by quite a bit. So you have a wide range, especially if you take just one sample from the population. So estimating population parameters from a larger sample. So yet now you are to estimate population parameters from a larger sample. So what happens if we take samples of 2 or more? For example, instead of just getting one sample from the population of 10, you just get one before. Let's say this time you get 2 samples. Okay. From a population of 10, how many ways can you select if the order of the 2 does not matter? Okay, so probably here you need a tool for especially the one who studied uh, earlier statistics, and that is known as combination. Okay. The answer, which is 45, can be found by using a graphing calculator. Actually, even without graphing calculator, just ordinary calculator, just look for the function NCR, okay, which is N combination. Yeah, this one. Okay. So N combination R. So the N here refers to the population. Okay. And the R is how many members or how many samples are you going to take at a time. So this would give you N is 10, 10 combination, and then you take 2 at a time. So 10 combination 2 would give you 45. So this would be the number of um, okay, the number of samples that would be okay. So increasing the sample size has improved your estimate. So there are now 45 possible samples. Okay, so ranging so you can make it ano, like 01, 01, 02, 03, 04, 05, etc. And all other possible combinations until you saturate it and make it until 45. Okay, so if you will observe the samples, um, there would be some of these samples that will be producing the same means. For example, 01, 02, 7, 8, 8, 9, and so on. And some of the samples will produce the same mean. Okay, so for example, so how do you get the mean of this? So 0 plus 1, 1 divided by 2, so that is 0.5. 0 and 2, 7 and 8, so divided by 2, you will get 1. 0 plus 1 is 1. Okay, 7 and 8, 15. 8 and 9, so forth and so on. So some of this example will produce the same mean. For example, 0, 6, 0, 6, 1, 5, and 2, 4 all produce a mean of 3. And 0 plus 6 is 6 divided by 2 is 3. Uh, 1 plus 5 is 6 divided by 2 is 3. 2 and 4 is 2 plus 4 is 6 divided by 2 is 3. Okay, so they will have a mean of 3. So the three dots above the mean of 3 represent these three samples. So let's take a look at the estimates of the mean. So this is the 3. So this is for the 3, not for the 2. Let's take a look at the upper portion. So there, this would give a total of 45. Okay, estimates of the mean from 0 to 9. Okay, so the 3 here would have 1, 2, 3. Okay, so for the possible combination for okay, so number of samples is 45. Increasing the sample sizes improve your estimates. Actually, what we are just trying to point out here is that okay, 4.5. This with the help of the graphing, but if you don't have the graphing calculator, uh, probably might as well just consider how many possible combinations you will have for two samples. So increasing the sample sizes improve your estimate. So there are now 45 samples. Okay, this is what I said earlier. So there are some possible or combinations that would be with the same mean. So they all belong together. So 0, 6 is 3. So as you increase the number of okay, so looking at the sampling distributions, okay, the 45 means are not evenly distributed as they were when the sample size was 1. Instead, they have clustered the true mean of $4.50. Okay, 0, 1, and 8, 9 are the only two samples whose means deviate by as much as $4. 0, 1 plus 8 plus 9 is 17. So also 5 of the samples yield the estimates of 450, another 8 deviate by only 1 plus or minus 50 cents. So if 3 people are randomly selected from the population of 10, for example, so instead of considering just 1 or 2, okay, you choose 3. So possible outcomes in the sample would be 120. So that would be 10 combinations. So you will have 120, which can be calculated with a graphing calculator. And the sampling distribution in this case is as follows. Actually, this would already be shown in the graphing calculator. However, in the absence, then you can just probably use some other means to be able to graph. The number of samples, we have 120. True mean is $4.50. So estimates of the mean. Sample size is 2. Okay. So here are the screenshots from a graphing calculated from the results of selecting 1 and 2, 3 people from the population of 10. So the 10, 45, and 120 represent a total number of possible samples that are generated by increasing the sample size by 1 each time. So for 1, just have to consider 10 possible combination from ranging between 0 to 9. The next is you have 45 for you have 2 and 120 for when you choose 3 people from the population of 10. So this would be the combination. 10 combination 1 stem, 10 combination 2 is 45. So we'll use this formula here, NCR. 10 combination P is 120. Next, the sampling distribution for sample sizes of 4, 5, and 6 are shown. Okay, so next in line. So this is for 4, 10 combination 4. You have 210. So we're going to determine the most likely the pattern of this graph. It's more likely of a normal distribution, bell shape. Okay, 4, 5, you have 252. So again, we have 10 combination 5. You have 252 possible combinations. Okay, so from the given graphs above, it is obvious that increasing the size of the samples chosen from the population of 10 resulted in a distribution of the means that was more closely clustered around the true mean. So as you can see, the more that you increase the number of persons that you get from the population, okay, it is more likely that the result that you're going to have clustered around the true mean, which is $4.50. If a sample size of 10 were selected, there will be only one possible sample, and it will yield the true mean of $4.50. Also, the sampling distribution or the sample means is approximately normal. Okay, normal, since this would be bell shape. Okay, you know what a bell is. So it's symmetrical. So when you say symmetrical, what you can see in the right would also be seen from the left. So also the sampling distribution is approximately normal, or as can be seen by the bell shape in each of the graphs. So now that you have been introduced to sampling distributions, how sample size affects the distribution of the sample means, it is time to investigate a more realistic sampling situation. Okay, so this is studying a population through sampling. Okay, so first, what most researchers do, especially if you have a big population, what you do is you just have to get samples, and the process is of getting samples is known as sampling. Okay, Professor, assume you want to study the student population of A university, sample A and A, to determine the approval or disapproval of a student dress code proposed by the administration. First here, in AMA, you know that we don't, students don't have their uniform, but um, the study that will be conducted, as an example, would determine the approval or disapproval of the student dress code. So even if you don't have uniform, of course you must adhere to what we call the dress code. Like for example, no clothes that